Hi, and welcome to another URI Astrophysics tutorial. My name is Eric Carlson, and today we're going to talk about using the VLA pipeline for VLA reduction of EVLA data. So, to start, we're going to go to the archive here at archive.nrao.edu. We are going to select download archive data files, and we're going to put in our project code of interest. So today we're going to use the 12B230 dataset, and we're going to submit our query. So we're going to put in our email address here, and we're going to put in our luster information where we want to point our data file. We're going to collect the SDM BDF dataset button so we can request all files, including the visibilities. We do not want to click the CASA measurement set, as the pipeline will generate that for us. For this tutorial, we're going to use the 12B230 measurement set ending in 875. And then we're going to select Get My Data. So from here, we're going to scroll down and we're going to retrieve over the internet, and this is going to write to our luster account. So after a few minutes, we can go to our terminal and SSH into our luster account. So once we're into Gygax, we can actually SSH straight into the master node. And when we go to our file containing the measurement set that we just processed, we can see that our 12B230 dataset exists right here. So once this is done, we can copy our archive file name here. And using the link in the description, we can grab the recursive shell script located in the Git repository below. And we can change line 14 here to include our archive file name. Scrolling down, we can adjust line 37 for the amount of memory needed to be run for this job. I recommend using about 10% of the measurement set to be loaded into RAM. You can use more, however, the scheduler will punish you for using higher amounts of RAM. If needed, we can request multiple nodes or multiple cores using the some of these different parameters here, which are commented out. We also need to change our email address on line 48. And on line 54, we can identify different versions of the pipeline which we want to run. So for the purposes of this pipeline run, we're using 6.1.1-13. So once this is done, we can copy this shell script. We can go back to our master node and generate a shell script. And we can paste in our shell script and write it out. So once that's done, we can make that shell script executable using chmod. And then we're going to run that shell script. So as we can see here, here is our measurement set repeated back to us, and the new file that was generated showing that we have where our pipeline products are going to be. It also gives us our job ID, which we can reconfirm by running the qstat on our account. As we can see, we've submitted a batch job here use it on our measurement set, which is currently running on NM post 18. So once this is done, in the next video, we'll review the different things we can do with the pipeline output for different imaging techniques using both CASA and DiffMap. If you have any questions, please feel free to leave them in the comments below.